Hi guys, welcome to my channel. Here we shall discuss a few questions for MEO Class 4 exams. To begin with, we shall start with the function 6, which is maintenance and repair at operational level, MROL, or we just say MEP. So let's go topic wise, and today we shall begin with boiler. Boiler, as you know, is a very important topic for these exams. And to begin with boilers, you should be well aware of what type of boiler you have sailed with, and if any major works have been taken place, and what were the particular works that you were involved in the contract period, and so on. But if you're not sure about it, or if you're not sure of what all works have been taken place in the boiler, because obviously as a fifth engineer or a trainee marine engineer, you will be busy with other works as well, and you might not be actively involved in maintenance of the boiler. It is completely all right to not mention it, as you don't want yourself to get into further troubles, as the surveyors can be particular about this topic and they can go deep into it, and if you're not fully aware of it, you yourself will be making yourself uncomfortable during your oral exams. So it's it's completely all right, because boilers are not a machinery which usually have a lot of maintenance, and you won't be in trouble more often than not for not mentioning it all. So let's start discussing a few important questions. All right. So one of the mostly asked questions while it comes to the topic of boiler is, what are different types of boiler water tests and its procedures? So you must have observed while on board that the third engineer collecting the boiler water sample from the sampling point and carrying out the test and recording the values obtained. So the surveyor, when he's asking you this question, will be expecting you to answer in a certain order. So I'll be explaining it to you in a similar fashion. All right. So the first test will be the phenolphthalein test. So for this, we take 100 ml of boiler water sample. Then we add 10 drops of phenolphthalein. So you'll find the color will change to pink. Now we add N by 50 concentrated sulfuric acid till the color vanishes. The quantity of sulfuric acid will indicate the phenolphthalein alkalinity of the boiler water. So second will be total alkalinity test. With this, what we do is that the sample which we have formed in the previous test, which is the phenolphthalein test, will be used for carrying out this test. So for this, what we do is that with the sample, we add 10 drops of methyl orange. After that, we observe that the color changes to orange. Now we add sulfuric acid till the color changes to pink. So this is how we carry out the total alkalinity test. The third will be chloride test. For this, the sample after P alkalinity test, that is the first test that is used again. Here we add 10 drops of potassium chromate. Then we find the color which changes to yellow. Now we add N by 35 concentrated silver nitrate. In the first test we used N by 50 concentrate. Here we are using N by 35 of silver nitrate till the color changes to brick red. This is how we carry out the chloride test. Now, next will be the phosphate test. Now, for this we take 25 ml of filtered boiler water sample. Then we add the reagent molybdate. Then we add a small spoon of stainless chloride. The color will change to blue. Then we use a comparator to check the phosphate level. Next is our pH test. For this, what we do is that we just use our normal pH paper by dipping it, by dipping the pH paper in the normal boiler water sample. By this, we can see using the spectrum or what at what range the pH is at. So next will be a hardness test. For this, we can use a conductivity meter or just a standard soap solution. We take the boiler water in a beaker, then we can add a soap solution and stir it for some time. And while doing this, what we observe is that when we find more foam in the solution after stirring, it means that uh, the hardness is less in the boiler water, and vice versa. So last is the conductivity test. Basically, it is directly related to the hardness test, which is the higher the conductivity, higher will be the hardness. Hardness of the boiler water. So once we carry out the hardness test, it will be easy to find the conductivity of the boiler water solution. And one more thing is that which the boiler water test results, which are not mostly generic. It depends. In different books you find different values, so it's not generic, but I'll help you with a few values which are commonly used. But again, if the surveyor disagrees with the values, there's no option but to listen to him, because it depends on surveys to surveys as well. So for the first P alkalinity test, what we take as a normal value will be around 150 ppm. And for total alkalinity, we use 300 ppm as a reference. And for chloride, it will be 300 as well. For phosphate test, it will be 40 to 60 ppm. And for conductivity, it will be 3000. And for pH, it usually becomes around 10 to 11. This is for conductivity test. Sorry for writing it in the wrong place. For the pH, it is 10 to 11. All right. So these are the values. So yeah, let's move to the next question. That would be, what are the different reasons for carryover? So for answering this, we can say it can be excessive phosphate, like which means we have used too much chemical in the boiler water while chemical treating it, or boiler water levels too high, rolling and pitching, oil in water, demister not functioning properly, and so on. The surveys mostly don't ask too much deep into such questions, but they might ask you what would be the consequences of this. Then you can answer that it would be erosion, scale formation, corrosion of the steam plant, and so on. Moving on to next question. What are the different types of boilers? Which one have you sailed on? And what makes it different from the others? So mostly in merchant ships, the boiler we use are either smoke tube type or water tube type. We also have composite type boilers, but the survey will be asking you to understand whether you have sailed in a vessel with smoke tube or water tube. But more often than not, most of the vessels use smoke tube type of boilers. So when he wants the difference, we can say what a smoke tube type of boiler is and what a water tube type boiler has. So let's begin with smoke tube type boiler. It has a lower rate of evaporation. It's a lower pressure boiler. It is less compact. The gases pass through tubes and water is surrounding the tubes. It's mainly used in low steam demand conditions, and it's comparatively has less control of the quality of water, and it has a more storage capacity of the steams. So when it comes to water type boiler, it has higher rate of evaporation, high pressure. It's a high pressure boiler. It's compact in size. In this type of boiler, the water passes through the tubes and smoke surrounds the tubes. and it's mainly used in ships where the steam demand is very high. It requires very good requires very good control of water, and requires proper water treatment, and the steam retaining or holding capacity of this type of water tube of this type of boiler, that is the water tube type of boiler, is comparatively very low. So yeah, that's about these two types of boilers. Moving on, what are the internal accessories or the mountings in a boiler? So most of us are aware of the external mountings because we focus on that mostly for our theory exams, right? But the internal mountings are the ones which we mostly ignore or are not aware of. So the surveyors make sure that they try to get such answers from you, whether you are well aware of what all are the accessories internally and externally of a boiler. So the internal accessories are the distributor and ring, demister, and a funnel. So the distributor and ring is the one through which the water enters into the boiler from the main feed check valve to avoid the thermal stresses in the boiler. And the demister is used to prevent any carryover from the boiler and to protect it from different steam machineries. And the funnel is through which the scum blowdown is being taken place. So these are the three internal accessories in the boiler. So the next question is, what are the safeties of gauge glass? And there are mainly two important safeties. First is the cork of water side and steam side of the gauge glass from the boiler open vertically downwards and not horizontally. Else, due to vibration, there may be a possibility that it will automatically close. And in this case, we will get a wrong reading. Alright, the next is the hollow steel ball. The hollow steel ball is in the water side. If the gauge glass breaks and if and the water comes, if there is no steel ball, the water will come out at its full force, which will be at least 6 bar of pressure. So we don't want that. So this hollow steel ball will act as a barrier and will reduce the force of the water coming out. So these are the important two safeties. All right. So another very important question in respect to the oral question is that what is the procedure for the gauge glass blow through? So for this, first we shut the steam side, then we shut the water side. After that, we open the drain at the bottom. Then gauge glass becomes empty. Then we open the steam side. Then the steam starts coming out from the drain, which means that the steam side is clear. After that, we'll close the steam side and open the water side. Then the water starts coming from the drain, and which means that the water side is also clear. Now both sides are cleared, so we shut down the drain. Now open the water side first and completely rinse the gauge glass. Then we open the steam side and see the accurate water level in the boiler. So why do we open the water side first and not the steam side? Which is also a popular question. The answer for this is that the latent heat of the steam is more comparatively to the water, as you all know. So the chances of breakage of the glasses are more because of this latent heat. So to avoid this thermal stress, we first open the water side. So another question which is related to this boiler gauge glass is the types of gauge glass, and which is mostly tubular type and plate type. Lately, the plate type of gauge glasses are widely used mainly because of the ability for the glasses which provide a long distance visibility for the level to be seen. Yeah, so that's it for the gauge glass. Next is a scenario-based question. These questions are generally asked by the surveyors when they have to check whether you are competent or you have the capacity to take over an independent watch. And this type of questions are very important because they are more of a break-even type of a question because these questions can determine whether you pass or fail the particular exam, the oral exam you have been giving, because these questions can give the surveyor the confidence in you and your knowledge about handling different scenarios in the engine room. So the question here we are discussing will be, you are on the watch, suddenly the low water level alarm of the boiler comes in the engine room. What will be your action? So based upon your experience in the engine room and different scenarios you have gone through, you can come up with your answer. The answer which I am giving here will be, when you hear the alarm, you first go and accept the alarm. Then we should go and stop the boiler, but make sure that you don't go too close near the boiler, or you go to blow through the boiler gauge glass immediately, because what in case you should expect all the worst case scenarios, right? So you just stop the boiler, and after some time you just let it to cool down for a while. Then you go and do the gauge glass blow through and check the boiler water level is okay, or whether if it's actually low as in this scenario. So if it's actually low, then we should never put the water immediately inside the boiler, because the boiler inside the boiler we maintain a certain temperature, and if the water level is too low, we should gradually only increase the water level, and there is a particular method to do it that we shall discuss later if you need me to discuss the actual method for doing it. So what we do is we don't immediately put water inside the boiler. We just follow the procedure by slowly increasing the water level, and that will be done later. So what we do is basically first check whether the gauge glass level is actually true or not, and then we let the boiler to completely cool down by providing it sufficient time. And after that, we check the condition of the furnace and make sure that everything is fine. So we add the water, and all other procedures can wait at some other time, but make sure that these procedures are followed correctly. So this is how I'll be answering the question. You can answer in your own way. The next question is, what are the different types of safety valve, and how much lift should be there so that accumulation of pressure should not be above the acceptable limits? First of all, let's talk about the different types of safety valves. First is the ordinary safety valve. In this ordinary types of safety valve, they do not have exhaust steam piston and no floating ring, but it will have wings. And the lift is D by 24. The second is high lift safety valves. In this, valves with wings and exhaust steam pressure are present, but no floating rings are present. In this type of safety valve, the lift is D by 12. The next and most commonly used is the improved high lift safety valves. In this type of safety valves, there are no wings, but it will contain an exhaust steam piston with a floating ring. The lift of this types of vessel of this types of safety valve is uh, L equals to D by 8. So the first question is done. Now let's go to the second part of the question. The second part of the question is, how much lift should be there so that the accumulation of the pressure should not be above the acceptable limits? Now, to find this, what we do is that we equate this formula: pi by 4 d square equals to pi dl, where L is the lift and d is the diameter of the valve lid. All right. So by equating it, what we get is that L equals to D by 4. So this is the minimum lift that is required for this safety valve to not accumulate any kind of pressure. Okay. So the next question is procedure for overhauling the safety valve and what all checks have to be done inside the safety valve. So if you have had the experience of overhauling the safety valve on board, it will be easier for you. Otherwise, you can follow this answer. So first and foremost, before opening the safety valve, you should make sure that you release the inside pressure of the safety valve because a spring is present inside the safety valve, as you know. So first, we should open the compression nut so that the complete spring pressure should be relieved. And then we should start opening the valve and then check for the condition of its seats, the valve's condition, then the mating surface condition, and check if there are any kind of grooves or scratches, and if there are any kind of dents, and in case if there are any dents, lapping will be required for clearing it out. And then we should check the condition of the spindle because the spindle will be carrying a lot of pressure because it's always under pressure more often than not while it's under operation, right? So we should check the condition of the spindle, and then we should check the condition of the spring, and for that you will have to just drop it from a certain height and check if there is the spring action of the spring is maintained or not. Then we should check the body for any kind of erosion or corrosion or any kind of fittings are there on the surface. After all this, you can box back the safety wall. Uh, but while doing it, you should make sure that the compression nut is tightened with respect to the previous marking of the compression nut. But this case is only done if there is no lapping has been done during the overall of the safety valve. Because if lapping is carried out, the setting will be changed, and it will create a difficulty in opening the safety valve while it's under use. So after lapping, you should reset the safety valve and then only tighten the compression nut. Okay. So the next question is procedure to do the setting of safety valve on board. So first what we do is we fire the boiler and then we close the steam stop valve so that no consumption of steam is taken place. After that, we bypass the HP cutout and then we put the gauging tool on one safety valve and set the other safety valve. Now we check the pressure on the gauge with the help of the compression nut, and then we check the lifting pressure of the safety valve, and we should make sure that it is not more than 3% of the working pressure. So once it's done, we do the same for the second safety valve as well. As we put the safety gauging tool on the first safety valve and do the setting of the second safety valve. After that, we put a split collar so that no one should change the setting of the safety valve. And then we put the cap and the lever. Then for extra safety, we put a padlock as well. So after that, we should make sure that we check the operation of the safety valve with the easing gear. So this is the procedure required for setting the safety valve on board. So our next question is, what do you understand by the term accumulation of pressure? So, in simple words, accumulation of pressure means that your safety valve lifts up, still the pressure in the boiler keeps on increasing ever slightly. But there'll be some standards that has to be followed. That is, if the pressure exceeds more than 10% of the working pressure in 7 minutes in case of a water tube boiler and 15 minutes in case of a smoke tube boiler, then the accumulation test will be failed. So that's about the term accumulation of pressure and how the test is failed. So how to perform the accumulation of pressure test? So for this, what we do is that we take sufficient water in the boiler, then we close the steam outlet valve. Then we bypass the HP cutout, Then we start firing the boiler with full force. Then we check the pressure and the time the safety valve lifts up and make sure that it follows the standards that has to be followed. That is, it should not increase the 10% of the working pressure in 7 minutes for a water tube boiler, and for a smoke tube boiler that is 15 minutes, as we have mentioned above. And it is also important that we make sure that it is never done at a point where a superheater is present. So that is also a very important thing that we should make sure while answering this question. Okay. The next question is, what do you understand by the term shrinkage and swelling of the boiler? So, shrinkage of the boiler means that if suddenly a boiler steam demands go down, then the steam pressure at the top increases and it will force the liquid downwards, and due to which the level of the water goes down, but in actual the water level is not down, but this will be sensed by the sensor, and this will start the feed pump for feeding the water inside the boiler, which we don't want, and this phenomena is called shrinkage. And swelling is directly the opposite of this. That is basically when there is a sudden increase in the steam demand, then what happens is that the steam at the top becomes less and the water starts expanding, and due to which it shows the increase in the level. But actually, the water level is not increased. So the sensor will sense this and it will stop feeding water into the boiler. And this term is called swelling of the boiler. So to avoid this, pumps works on the three element control method. That is basically the water level, steam flow rate, and the water flow rate. These three elements are checked, and then only the pumps will start. So, hence, the shrinkage and swelling of the boiler is stopped. So, the next question is, what could be the reasons if you will not be able to maintain the water level in the boiler? So, the first would be the drop in the feed water pump's efficiency. Second is the distributor ring holes being choked in the main line. Third is the tube inside the boiler leaking. This can be identified by checking the hot well level. If the hot well level is decreasing continuously and the blowdown walls are also shut, this means that the leakage is inside the boiler tubes. But in case the hot well level is decreasing, you should also primarily check whether the blowdown walls are also closed. In some cases, the blowdown walls are kept open and the water level keeps on decreasing. And another reason could be controller malfunction. And another reason is vapor lock, in which case the pump loses its suction. So these are the reasons that you can say that uh, we are not able to maintain the level of water in the boiler. So the next question is, what do you understand by the term backfire in the boiler and precautions to prevent the backfire in the boiler? So, first, let's talk about backfire of the boiler. If by any reason fuel is accumulated inside the boiler furnace, which mostly occurs due to repetitive fail in the start of the boiler. So at that time, the oil catches a sudden fire, and this results in the huge rise of pressure in the boiler furnace. And this pressure is so much that the gases will come out from the burner side. So this is basically what boiler backfire means. So to prevent it, what all we do is that we make sure that we maintain the burner in good condition as much as possible. And also, there might be some kind of leakage in the burner. So this should also be made sure that it's avoided. So another way is that we make sure that we do not backpass the pre-purging and the post-purging process before and after the boilers starts and stops. So these are the few steps that we can take care to make sure that the boiler backfire is avoided. So the next question is different types of boiler burners. So basically there are three types of boiler burners. Those are pressure jet burners, rotary cup burner, and steam assisted or white type burners. So when they ask the question about the boiler burner, they are more certainly likely to ask the question about what the turn down ratio is, because it's directly linked with the burners and the selection of the burners. So turn down ratio is basically the ratio between the maximum pressure to the minimum fuel oil pressure in which the burner works satisfactorily. So while mentioning the burner, we should talk about their turn down ratio as well. That is, for pressure jet burner, turn down ratio is around 2 to 3, which is not suitable for modulation control. And for rotary cup burners, the turn down ratio is 12 to 13. Here we can not control the quantity, but we can control the speed. And in case of steam assisted or the Y jet type bu types of burners, the turn-down ratio is 18 to 20. Here, the requirement is there of a continuous steam supply. So this is about the different types of burner and the turn-down ratio. Okay. The next questions are how to check the burner is working fine or not. And lead question will be how to fire the boiler if the pilot burner transformer is burnt out and if there is no spare. So let's deal with the first question first. So first of all, to check whether the burner is working fine, we should check the color of the flame, that it should be bright orange. And secondly, we can check the exhaust of the boiler and check the color of the smoke. If the color of the smoke is black, it means that less air is provided for the burner. And if it is white smoke, that means air provided is more or the water in fuel oil is more. So uh, for the second part of the question, in case we don't have spare of the pilot burner burner transformer of this boiler, we can use the spare step-up transformer of the incinerator, because even for the incinerator pilot burner we use a step-up transformer that is similar to the one which we use for the boiler's pilot burner as well. So these are the answers for these questions. So the next question is, what is water hammering? What are its causes and how to prevent it? So let's start with what water hammering is. So basically, when water accelerated by steam pressure is suddenly stopped by impact of walls, bentings, pipe fittings, or whatever, in that case, the kinetic energy in the water is converted into the pressure energy, and the pressure shock is applied to the obstruction. And this can cause different issues. Like in case of major hammering, it can even burst the pipelines and the walls. And normally, it creates an unwanted sound. So this is about water hammering. So it is usually caused by the boiler carryover depositing large amount of boiler water in the steam mains or backflow from the condensate mains. So these are the causes. So now we should focus on how to prevent it. So mainly what we should do is to avoid it, we should have proper drainage after the operation of the what you can say of the lines once you use the steam. Usually, it is used for cargo operations in large quantities for the cargo operation. So, in the steam lines should be properly drained. Then, what we can do is that we should ensure the quality of the steam is very good, and we should maintain it as good as possible, and we should also make sure that the steam velocities does not exceed the required velocities. And then what we can do is that we can uh, use steam traps in with respect to the capacity. And another thing is that we should make sure that the pipings are what do you say, well insulated, and there are as less obstructions as possible, so that there is no place for this hammering to occur. So these are few of the uh, methods you can use to prevent the hammering. So that's it about this question. So the next question is the possible causes for a flame eye failure in the boiler, or it can be asked like what are the reasons for the flame eye failure uh, in the boiler while trying to fire it. So the answers would be faulty flame eye, or improper air present for combustion, or whether the fuel oil might be cool, or no proper fuel oil pressure for the burner. The swirling action is not proper due to improper burner maintenance, and can also be presence of water in fuel oil. And pilot burner fuel oil filters can be choked, and they can be because of improper electrode cables, or maybe the filter of the main fuel pump can also be choked, and the distance between the electrode of the main of the pilot burner can also can also lead to this flame failure. So these are the answers for that part. And some surveys might ask you how to check the working proper functioning of the flame eye. So for that, what we do is we connect the uh, output terminal of the flame eye to a multimeter. Then we show light onto the flame eye and then see the continuity. So this is how we check the functioning of the flame eye. So the next question is, what is economizer fire? What are the reasons for it? And what all actions are carried out in case of an economizer fire? So I hope you all know what an economizer is. And usually, because of the exhaust gas, there are a lot of carbon deposits over time on the atomizer tubes. So what happens is that usually in the dry form, the carbon is not so harmful because its self-ignition temperature is 1,000 degrees Celsius. But when the carbon becomes wet, that is because of the fuel oil or the lube oil, which comes in contact with the carbon, which makes it wet. In this case, the self-ignition temperature will drop to 200 degrees Celsius. So, in that case, the carbon which is wet will suddenly catch fire. So, mainly the reasons for this is that uh, mostly because of the improper combustion in the main engine. It can also occur when there is maneuvering happening for a very long time, and also when the improper lube oil feed setting is given. There, it can give unwanted amount of lube oil, which can be carried to the exhaust gas, and this is also a reason why the carbon becomes wet. And another reason would be the improper maintenance of the injector, which causes ripping of this injector. And the last reason is because of the leaky exhaust valve. So basically, there are two types of EGB fires or economizer fire. That is minor fire and the major fire. Major fire is basically hydrogen fire or metal fire, which is undesirable. And for in this case of fire, a lot of actions will be taken place to contain the fire. So let's talk about the actions that is carried out in case of an economizer fire. So what we do is, first and foremost, we make sure that the boiler water circulation pump is continuously run as long as the hot well level doesn't decrease, which indicates that the tubes are leaking. So in this case, we don't want the economizer, I mean the uh, boiler water circulation pump to be running, because this can lead to the hydrogen fire. So in only in this case, we turn off the exhaust, not the exhaust, the boiler water circulation pump, and we make sure that we don't carry out the soot blow. We inform the wheelhouse, and we slowly stop the main engine. We stop the blower. We also close the turbocharger drain, and we put a canvas on the boiler on the blower side of the turbocharger, and we close all the scavenge drains. And in case the boiler is running, we stop it as well. So in in most of the ship, there are fixed firefighting system for such in case of such fires. So we directly operate it, and we try to contain the fire. And as mentioned above, we should make sure that the boiler water circulation pump is continuously run until and unless there is a drop in the hot well. So that is for this question. Okay, so this is the end of our session on the topic boiler. I hope that I have discussed at least a few important questions with respect to the oral exams. In case you have any doubts or queries, please let me know through the comment section, or you can DM me in Instagram as well. It's still my early days here, so please, your suggestions and support will be invaluable. Thank you so much for your time, and I will be back with another topic as soon as possible. Until then, happy learning.